not exactly. Okay, sit down, sit down. Hello, Mr. Eric. Hello, Mr. Ryan. Hello, Mr. Teacher. Say.
Hello, Mr. Teacher.
Oh, okay. Okay, so today we're talking about the linked list. Link. L-I-N-K. Linked list. Linked list. So can you tell me what do you think a linked list would be?
A list that's linked.
It's another data structure. So the linked list consists of nodes, a linked node. So each node, you can have a value, yeah, any type of value, and then you also have a next pointer, yeah, pointing to another one, yeah. Next, okay. So you see this is going. So we can create a new node and then we can put it into the chain, yeah? So it's like, you know, so it's like you have a chain and then a node can be linked to another node, to another node, okay? Yeah?
A chain is like this.
Yeah, something like that. Yes, yeah, a chain, yes. So these are the nodes, yeah, and the connection is one way, or it can be this is called a singlet linked list because it's pointing to one location, to one direction only. But if we add another one backwards, yeah, we can also add another direction to link it backwards like that, yeah.
Yeah, like that.
Then that would be double link. Double direction link.
W.
Yeah? Double link list.
Double, not double.
Okay, double the link list. Okay. So it's quite similar to the list in Python. Remember we use the Python here like numbers. Yeah. We always use numbers, and then we can put this 1, 2, 3, right? 4.
Yes.
So this is the number. This is called a list.
This.
The thing is that in Python, if you're doing this, these numbers are stored in the computer memory, computer memory, yeah, like a memory, continuously. So it will be, so the list address will be like that, yeah?
Yeah.
Okay, so now if you put another number on it, and then it will be append at the end, right? Yeah? Okay, so this is called a list, but we are using the single list link here, and then these nodes in memory could be in different places. So this value will be somewhere here, and then will link to another place in memory, and then link to another place in memory. Yeah. So this next is pointing to the next node. Okay. So what's the advantage of using that? Can you think of any advantage if compared to this? You probably don't know because in LAMs in this list, computer pre-allocate a space, continuous space like 10 elements to store these numbers. Yeah. If there's more than 10 elements, and if you want to add another one, so computer doesn't have enough memory to hold these 10 numbers. So what it does is it will find another space which is can hold more than 10 elements, and then you will copy all these numbers to the new place. Just move it. Suppose you have a table, but it's very small. You put the 5 toys on it, and then I give you another 1 toy. I want you to put it on the table, but you're running out of space on the table. So what do? So we find another bigger table, and then move these 5 toys, with that.
6 toys.
6 toys, yeah, together to the new table. So it takes time, right? Sometimes this, if you append it, in the worst case, the time complexity is and if running out of space, right? But this linked list, the advantage is that no matter you can find a space anywhere. So the time complexity to add a new node to the end is 1. Yeah, we just have to, because the link never change. We just have to allocate one and put it to attach it to the end, right? Yes, and then so if you are given this head of the link, yeah, it takes O(n) time to travel the linked list, right? Yeah, because you have to start from the beginning and then you follow one step at a time and to find the end. Okay? Yeah, okay, so now let's write this class. So look, linked list. So linked list, we have a node, yeah, we define a node, yeah. So class, what is class? Object template. So it defines how we create the new objects. Class node.
See,
What's the missing? Yes. And then we define the constructor in int, yeah. And then if it's the method of the class, the first parameter is usually self. Okay, so it means that this method belongs to the class. And then the value means that we can hold any type of value and then we can point to next node or just next, yeah? Next. And then by default, if we not specify anything, we just specify it as a noun default value because it's pointing to nothing at the beginning, unless we specify the one node. And then we can say, we can add self dot, yeah, we're using this self dot value. We given a new attribute to value, and then self dot next equals next. Okay. So let's say defining a class in Python is very simple. Yeah, you just have this class. This is a constructor in underscore in initialization. Yeah, initialization means that when a class is initialized, is created. Okay, now we do this. We allocate two attributes by given a parameter. So now we can just do this. We can just like the first node head, and we can say node. We can just use it node -1. Okay, so it means that after this we're creating a node with the value -1, but the next pointer is none, right? Because if we are not given anything, the second parameter, and the by default is none.
So P equals
head. Not yet. So now we can define another one called defined at next and a node. Okay.
Self value.
Okay, then we can say if we add a node, yeah, value. So now what does it mean? It means that we add a method and then we create a new node and put it to the current node, yeah?
So node equal node value.
New node, yeah, we're creating one, node.
With a new node.
Value, yeah? And then self dot next equals new node, yeah? We're appending to the end.
New node.
Yeah, it's okay to return the new node, yeah? Okay. So now, if this, it means that if we have a node, yeah, I have a node head, and then we add a new node, then what you created will be, I created a new node 1, for example, and then I added link to it. I added link to it.
Yeah.
Okay, so remember this? Wait. So remember this, yeah? Okay, now if I write a program and you tell me what will be the output. Okay? So now if I have this headphone. Node. Head. Node -1, okay?
Equals head node.
And then I have interesting. If I have for I in range like 10, for example, column.
Why in range 10?
No, I will write the program and then you tell me what's the answer, okay? And then I can say if I have this P equals head, okay? And then if I can say P dot add the node, remember? Add node I, okay? And then this will return the next node, yeah? And then if I have say P equals P, add the next node. Okay, now after this, then I can say no. Then I can say P equals head. Okay, why? P is not long. Print P dot value.
What?
P equals P dot next. So do you think what's the output of this program? That's it.
-1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Wow, how do you know? How do you know? Can you tell me why? Yes, exactly. That's the output.
For I in range goes up to 10, but it doesn't do 10.
Yeah, so
Then
this.
I have to get out 10 numbers.
Yeah, exactly. So first of all, we have look. What it does is first of all we create a node. We have created a node which is -1. Yeah, -1. But we pointing to nothing yet. And now we save this P here, right? P is pointing to this, and then P at node I. This will be 0 to 1, 2, 3 to 9, right? Yeah. What it does is every time I create a node with this value 0, 1, 2, 3, yeah, and I put it here. This is now I'm 0, yeah, and then this P add link to it, and then P now moves to here, and then 1 I create a node 1 and I link to it, and now P moves to here, yeah. So eventually there will be a link -1, 0, 1, 2, 3, 4, 5, yeah, to 9. Okay, and then now P equals head. Head is here. Yeah, head is here. P equals head. So P pointing to here, and then now why P is not reaching the end, we print the value. So which is -1. P equals P dot next, and then move the P to the next. Yeah,
0.
and then move it to the next. Print it. So it just follows the linked list. Follows the note in the linked list. Yeah, got it?
Yeah.
What's the time complexity?
O-N.
Yeah, if this is n, then that's O(n), right? O(n), because we are creating the space. What's the space complexity? How much space do we need?
If that's N.
Then will be O.
1. N.
N, because we are obviously allocating the space for each node, so that's O(n), right? Yeah, so the space complexity and the time complexity is also O(n).
It's always O-N.
Yes, so this is quite interesting. Yeah, you see, this is another data structure. I created a node, a chain. You can imagine that's a chain, yeah, and I link it together. Okay, yeah, link it together. Yeah.
This is a chain. That's a weapon.
Okay. So any questions so far?
No. Say bye-bye.
Say bye-bye.
Bye.
Bye.
Bye, moon. Bye, moon. Bye.
Bye bye.
Bye.